Okay, guys, we are on to section 3 of chapter 4. We'll call it chapter 4.3. Okay, so this is actually the last section in this chapter. So we're going to finish this and we're going to study the chapter review. This wasn't a real long chapter. Our next chapter is over equations, which is basically having an equal sign and summing it out. So this one, translating verbal expressions into variable expressions. This is just, I think, making them practical. So to translate a verbal expression into a variable expression, give the expression given the variable. One major skill required in applied mathematics is the ability to translate a verbal expression into a variable expression. And we've done some of this year in the classes, but this is a little bit higher, so follow with me. This requires recognizing the verbal phrases that translate into mathematical operations. A partial list of the verbal phrases used to indicate the different mathematical operations is given on the next page. So translate 14 less than the cube of x into a variable expression. So identify the word that indicates the mathematical operation, less than. So right here we have less than the cube of x. So to make x a cube, remember when we cube something, we're taking it to the third dimension. That is because that is squared. Right now it's in a square. But if we put it into a cube, we're going to put dimensions back on it. So it becomes a cube. And you not only have to square it, you have to times it by the going back, a third dimension. Okay, so basically what this is saying is 14 less than the cube of x. So we have the cube of x, which is x to the third, minus 14, because it's asking for 14 less than the cube. If you guys remember this summer or this school year, we did story problems. We did a lot of less thans and more thans and stuff. Same basic idea here. That was all prep work for algebra. Okay, translating a phrase that contains the word sum, difference, product, or quotient can be challenging. In the examples at the right, note when the operation symbol is placed, or where the operational symbol is placed. And remember, quotient means division. Sum means addition. Difference means subtraction. And product means multiplication. We had those up on the board. So the sum of x and y, basically that's x plus y. When asked for the difference between x and y, it's x minus y. The product of x and y means x times y, and they use the little dot there to show times. And that is a way of times. Now, technically, as a algebra goes, you could just put xy, because that automatically means multiply, but they put the dot there to help you out. They're not going to put an x there, though, because it's not xxy. Okay, the quotient of x and y. So you have x divided by y. And remember, they show this for the division sign, and this is just this number divided by this number. That is a fraction, or what division is. Okay. The difference between the square of x and the sum of y and z. So they show x squared, because you want to find the difference between the square of x. So they've got the square of x and minus, because it says difference. And then they put y plus z in parentheses, because it didn't ask you for the sum of it divided by y and then divided again by z or anything. So it wants you to, it asked for the sum of y and z. So they put them in parentheses, so you find out the sum before you do the subtraction. So hopefully that made sense. I might have goofed up a little bit on my words. Okay. Translate the total of 3 times n and 5 into a variable expression. So basically we go 3n, because remember, we don't have to put a space in there. We could put times, but don't need to. 3n and 3n and 5 into a variable expression. So it's just 3n, 5. Now we know that we're going to be adding them because of this word total. So it wants the total of 3 times n and 5. So what it's asking is, after you figure out 3n, you add 5 to it. Pause this and figure out that you try it one on your own. At least study it. Okay. Words or phrases for addition. We go added, more than, the sum of, increased by, the total of, plus. And again, the reason this book is so repetitive on this is stuff that we've covered in a lot of previous chapters, but we need to cover it more so that you guys can link it to algebra, because this is right here. And actually, and from here on out, we're studying algebra. This is at least 8th grade math, at the beginning of the 8th grade year. And for those of you guys who are going to be studying principles of algebra in high school, you're going to slip right in. You're probably going to know a lot more than the class starts with. And that is so awesome. Okay, words or phrases for subtraction. We have minus, we have less than, we have less, we have subtracted from, we have decreased by, we have the difference between, x minus 2, 7 less than t, 7 less t. So actually what you're taking is 7 and then you're minusing t. 5 subtracted from d. So remember, when it says subtracted from, you're always going to put this number second, because it's going to be this number minus this number because of that word from. M decreased by 3. So it's just m minus 3. The difference between y and 4. So it's just y minus 4. Word phrases for multiplication. We have times. We have of. we have the product of, we have multiplied by, we have twice. Technically, when you're reading word problems, you should also figure each into those. Each goes in both addition or multiplication and division. Like if you have 2 boxes and each have 5 pencils, how many pencils are you going to have? Well, that word each means that each of those 2 are going to have 5. So you multiply 2 times 5. If you have 10 pencils and you're going to put them in each of 2 piles, well, that would be dividing them between the 2 piles. You need to watch for that stuff and do the problems. Do them repetitively so you figure out what numbers go where. Okay, divided by x divided by 12. Now we have, that's just x over 12. And they are doing division now with this line. Generally, I don't think, since I've been doing algebra, I really ever do division like this. And on your keyboard, division is right under the question mark sign, and you have that dash. That dash means division. It's this number divided by this number. So be prepared for that. Okay, the square of, the cube of. These are phrases for powers. And powers are the numbers with the little dot up, with the little thing up there, the little number that tell you to multiply it by itself however many times. So you have x squared, you times x by x. You have a cubed, you times a by a by a 3 times. It's not 3 times a, it's a times a times a. Doing it 3 times. Okay, translate m decreased by the sum of n and 12. So you have m minus, and they put these in parentheses there so you figure out what n plus 12 is before you take it away from m. Let's do the you try it over here together. You can hit pause if you don't want to listen to me talk and want to try doing it on your own first. The quotient of 7 less than b and 15 of b and 15. Okay, so we're dealing with quotient. So we're going to say the quotient of 7 less than b and 15 into a variable expression. So we go b minus 7, and it asks for the quotient, which means division. So we're going to divide it by 15, I would guess. So if b were 22, it would be 15 divided by 15, which would be 1. But we don't know what b is, so we can't make assumptions like that. But we can simplify it or write out our problem. Later on, we might find out what b is. Okay. The translation of a verbal expression into a variable expression, and then simplify. In most applications that involve translating phrases into variable expressions, the variable to be used is not given. To translate these phrases, a variable must be assigned to an unknown quantity before the variable expression can be written. Oftentimes I just use x or y, but sometimes you use a or you use the first letter. That's what we did in class a lot this year when we were doing people's names. Like Bill is 7 years younger than Jill or whatever. Okay, translate a number multiplied by the total of 6 and the cube of the number into a variable expression. The unknown number n, which they're just throwing it in n, and assign a variable to one of the unknown quantities. So it's just any variable, and they decided to use n. You might use y or x, but the cube of the number. So we have n cubed, because we know the number multiplied by the total of 6 and the cube of the number. So we have, we know we're going to have n cubed in it. So the total of 6 and the cube of the number. So you know you're going to have 6 plus n cubed. So we'll have to go back up. Translate a number multiplied by the total of 6 and the cube of the number. So we're going to go 6 plus n cubed. I'm going to put that in parentheses. Then over here they show us that n. That n means it's multiplied. So that n being right next to the parentheses means everything inside that parentheses is multiplied by n, because it says a number multiplied by the total of 6 and the cube. Okay? And there, you got the whole thing written out. Okay, I'd pause it and go over these examples. It's getting kind of late for me. Do these examples and pause it. Okay, now we're going on. Pause it and do these examples. Ooh, my favorite shape. Favorite shape to figure out. Okay. To translate an application problems. Many applications in mathematics require that you identify the unknown quantity, assign a variable to the quantity, and then attempt to express the other unknown quantities in terms of variables. Okay, so the height of a triangle is 10 feet longer than the base of the triangle. So we know the base is b, and then we take the base plus 10, which is the height. The bottom to the top point is 10 feet higher. 10 feet higher. So we do b plus 10. So the base of the triangle is b. The height of the triangle is 10 more than b, so it's b plus 10. If you guys want to pause this and read over all of this right now, feel free. But okay, I'm going to ask you to pause this now. I'm hoping you guys have had pieces of paper out throughout this whole section, throughout this whole book, and have been writing everything down, because this is important stuff, and I know each of you guys is going to grow immensely. Okay, well, look at that. We are finished with chapter 4. Next, we'll be going on to chapter 5. I am going to click pause. I won't do all these with you, but maybe I'll do one. The sum of 7 and 3 times n. So we go the sum, so that means plus 7 and 3 times m. So we go 3m. Now, because this is not an equation, it's just an expression, we cannot figure out the answer. But that's next chapter. Okay, and next chapter is going to be a lot of fun. Okay, so that's it for the expression. And number 2, 12 less than the quotient x and negative 2. So we go x negative 2, and it's 12 less than the quotient. So we go minus 12. So you figure out what x divided by negative 2 is, and then it's 12 less than that. We don't have any way of figuring that out right now, but anyways, pause it if you haven't paused it, and do all the problems. Okay, pause it and do all the problems. I'm not going to go through all of them with you guys. This is good building up for you guys. Number 8, it says a less than 16. So we go 16 less is minus a. Okay, so pause it because I'm moving on. All right, pause it and do all these problems. There's a whole bunch of problems to do on all of these, but it's all good work for you. Let's drag my head over here. Okay, I probably should have done that at the beginning, but oh well. Let's pause it and go on. Pause it. All right. Pause it and do the problems. 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 Okay, we are to the very end of chapter 4. This is a chapter 4 summary. Keywords. A variable. A variable is a letter that is used to represent a quantity that is unknown or that can change. A variable expression is an expression that contains one or more variables. There's examples off to the side. The term variable expression are the add-ins of expressions. Each term is a variable term or a constant term. A variable term is composed of a numerical coefficient and a variable. So you would have 7x or whether there's x squared, y squared. In a variable expression, replacing each variable by its value and simplifying the resulting numerical expression is called evaluating the variable expression. So when it tells you what b is, b minus 2, that's evaluating it. And on many of the probes that we'll do in class this year and next year and so forth, will give you numbers. They'll say, if 5 equals x, what's x plus 3? Or something like that. Okay, to simplify the sum of like variable terms, use the distributive property to add the numerical coefficients. This is called combining like terms. So we can combine 5y with 3y. We can combine 5 plus 3, but actually that would be we can split up the 5y and the 3y to just 5 plus 3 times y, which ends up being 8y on either side. Okay, the additive inverse of a number opposite the number. So negative 4 is the additive inverse of positive 4. Okay, so it's negative 4 is positive 4. And if you add those together, you are going to get 0. Remember, this next chapter, I'm often going to be asking, okay, what is the opposite of plus 5? Well, if you know that's negative 5, it makes it a lot easier. Okay, the multiplicative inverse of a number is the reciprocal of the number. So if we have 3/4 and if we're trying to divide, say, a number, well, if we're trying to divide a fraction, we times it by the inverse, the reciprocal. So 3/4 is 4/3, which when you multiply them, it is 1, because you're doing 3 times 4, which is 12, and 4 times 3, which is 12. Negative 1/4 is the multiplicative inverse of 4, and that is of negative 4. And that's just because under any whole number or any number, you can put a 1 under it and make it into a fraction. Essential rules, the distributive property, if A, B, and C are real numbers, then A times B plus C equals AB plus AC. It's just the distributive is you're distributing this to this and this to this. So you're getting AB and AC. The associative property of addition is moving A plus B plus C is the same as A plus B plus C, just moving the parentheses. Commutative property is A plus B is B plus A. Addition property of 0, if you add 0, you're going to get the same number because you're not moving anywhere. The inverse property of addition, we just covered that. It's A plus negative A equals negative A plus A is always going to equal 0 when you're adding the opposites. The associative property of multiplication is A times associative is A times B times C equals A times B times C. It's moving the parentheses. The commutative property of multiplication is a times b is the same as b times a. So if you take 1 times 3, you're going to get the same as 3 times 1. The multiplication property of 1. Any number times 1 is going to be the same number. So if you only have something one time, that's all you're going to have it. The inverse property of multiplication. We went over that in the one above. A times 1 fraction a equals 1a times a. So it equals 1. So yeah, basically it's look over here at the example. Basically that would be what you're doing. You would be doing over that. So you'd be doing 3x over 1 times 1 over 3x, and that answer is always going to be 1. Okay, review and exercise. I'm not going to go over all these because I'm getting tired. Okay, and this is review over chapter 4. Our next chapter we'll be going over is chapter 5, and we will be doing equations, which that means we will be finding out the answer. So pause it and do this. Let's go pause it and do this. Let's go pause it and do this. Let's go pause it and work on this. Pause it and work on this. Now we're into chapter 4 test. So we're simplify 3x minus 5x plus 7x. Well, there you're only dealing with x's, and everything's the same, so you're going to go 3 minus 5, which would be negative 2, plus 7, that should be just 5x. Check me on that, make sure I'm doing it right. But you don't have to combine like terms. On number 5 you do, because you have the minus 7y, and the y's cannot be combined if you don't know what they are. So pause it and do all of these. Pause it and do all of these. Pause it and do all of these. Cumulative review. Okay. Pause it and do all of these. 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 Oh, looks like we're at the end, so pause it and do all of these. Now I'm going to give you guys a sneak peek at chapter 5, solving equations. Now we're going to be learning how to solve the equation. So let's go. That's wanting to know this. It's a solution. Is negative 4 a solution of 4 plus 5x equals x squared minus 2x. All you'd have to do there is plug in -4 for x, I think. So, yeah, that's what they show doing right there. We're going to be getting into finding out the answers to variables. I don't know where all that's going to happen, but hope you guys are learning a lot this year. We have finished chapter 4. We're going on to chapter 5 now, and we will shortly probably be on to chapter 6 before long. I don't know how much higher I'm going to go than chapter 6, because then you're getting into more high school level math. Upper high school level with the but I might do it too, because I think it'd be cool. So have a good day.